Welcome to the Stratasys booth here at EuroMold 2014. I'm Fred Fisher. I'd like to give you a tour of what we call our Application and Technology Showcase. What we're showing inside of this aircraft interior is an example of how designers and engineers are using additive manufacturing to help streamline both their design as well as their manufacturing process. The story we have on display here is in the context of an airliner, but we believe it's relevant regardless of the product that someone is producing, whether it's a lawnmower, a microwave, or an automobile. The story is still relevant. On the seats that you see here, all of the plastic parts have been created, a prototype has been created to help designers test both form and fit. So the green part that you see, the seat end cap that you see down here, the actual cap on the end of the armrest, those are examples of what we'd call a concept model. It's helping the engineer or designer understand both the form, right, the kind of final look and feel, as well as the fitment of that particular part. That happens with some of our rigid materials. In addition to that, what you see, the actual armrest here was actually made from some of our rubber-like materials from our PolyJet technology, and can show how we can make a dual material part. So this is a rubber material, and underneath here, although it's, you can't see it as it's installed, is actually a rigid back, right? It's the digital ABS on the back side and the actual Tango Black Plus on the top side of this. And once again, so it shows how our technology can be used to help designers and engineers understand both and validate the form and fit, and make design changes very early in the design cycle, where it's a cost and, let's say, time beneficial to make those changes very early. Now, in addition to what we show on display here are examples of how our technology is used for manufacturing related applications as well. So not just form and fit or functionality testing, but actually used for manufacturing related applications. So what you see, the wall panels here are examples, again, how a company certainly could use this to test just the form and the fit. But in this case, where the volumes are relatively low, let's say the product complexity is relatively high, this can be an example of how someone can directly produce a part from an additive manufacturing piece of equipment and actually use it in the final product itself. So the wall panels are an example of that, again, if someone were making, let's say, ones or tens or maybe even very low hundreds of volumes, maybe this might make sense for them before going to, let's say, conventional tooling is an economically viable route. Primarily, what we're showing also inside the airline, the showcase here, are like the ducting. So the chaseway that you see up on top here, as well as the electrical clips, these represent examples of really where additive manufacturing, specifically FDM, is a sweet spot for creating finished goods, where these are generally, although we're showing them through a translucent glass here, generally these would be, let's say, behind the actual skins or the structure, in this case of an airplane, that the consumer or the passenger on the plane wouldn't necessarily see. So the aesthetics aren't necessarily critical, but there absolutely are very complex shaped parts that are produced in relatively low volumes. That's really the sweet spot of where additive manufacturing fits, is exactly that, where the complexity is high, the part volume or the product volume is low, and that's generally what you see on display in the airline, or what you would see in an airplane itself, right? Many of the components behind the actual fuselage or behind the skins of the fuselage exactly fit that profile, and certainly the ducting quite complex in shape. So to produce this via traditional methods with thermoplastic materials would be relatively expensive and also time consuming for a company. This gives them a very economical and let's say technology viable path to put parts into service and to also customize parts, or to tailor them to maybe the specific vehicle or the specific product or person. Same story with the electrical clips that you see up there. Again, examples of relatively low volume parts, right? These generally would be made in the hundreds or maybe low thousands for vehicles themselves, and represent an example of where finished goods is possible with FDM or PolyJet technology. And so one other example then that we have on display is actually comes on the seat itself. So occasionally the direct output from our technology isn't sufficient in terms of mechanical, chemical, thermal, or other part properties. When that happens, oftentimes we can help companies get to their final product, whether it's metal, composite, plastic. We can help them get to that final product by not creating the actual part in our technology, but creating a tool to get them there through a traditional tooling process like sand casting, injection molding, blow molding, silicone molding. There are a few parts that are on display here. The actual leg of this particular seat structure was made by a sand casting process where the master pattern for the sand cast was actually a polyjet part. Now it certainly could have been polyjet, could have been FEM. In this case it was polyjet. That leg was made via a sand casting process where the pattern was polyjet. So it's an example of where someone had a requirement, in this case the requirement actually is to have a physical metal part, and we can help get them there relatively inexpensively by not creating the part directly, but again creating the part, let's say indirectly or via a tooling process. There are also some other parts on display here. If you actually look at the actual seat pans themselves in the actual vehicle, these seat pans represent examples of how we can be used for sheet metal forming as well, right? So you actually bend metal over top of plastic. So these sheet metal pans can be made via an FDM tool where we actually take flat sheet stock and form it either through hydroforming or a rubber pad press to conform it or form it to the shape of the tool, and then get a sheet metal, physical sheet metal part. So once again, what we're showing here in the application and technology showcase is how additive manufacturing is helping companies transform both their design as well as their manufacturing related processes. And we believe that the story that we have on display here, again, is relevant regardless of the industry or the product that a company is producing.